Today I will show you several homework problem solving. Question number 14, chapter 2, question number 14. Here is for chapter 2, question number 14. Indicate the number of protons, neutrons, and electrons in each of these species. I'll just show you one, the rest will be similar. Show you one is copper 29, 63. So how many protons for this symbol? Proton number is this smaller number in the lower left corner, so 29. The electron equals the proton because the symbol no charge. This is copper atom. Proton equals to its electron, so also 29. And the neutron number is the difference between this larger number and this smaller number. This larger number is mass number. Mass number equals to proton plus neutron. And the smaller number is proton. Right? Proton plus neutron. And this proton. Then subtract them, give you neutron. So 63 minus 29 give you 34. In order to explain further for this number of proton, electron, and neutron, I'll give you more example, but this is not from your textbook question 14. I just think about this. If this potassium iron, potassium plus 1, positive 1 charged iron, 1939. Then how many protons? Proton always is smaller number, 19. And how many electrons? If no charge, then this proton equals to neutron. Now this is positive 1 charge. Because here is a positive 1 charged iron. This means lost 1 electron. Then 19 lost 1. 19 minus 1 is 18. And how many neutrons? Neutron always the difference between mass and proton. So smaller number is proton number, and the larger number is mass number. Mass equals to proton plus neutron, then minus proton is neutron number. So 39 minus 19 is 20. Give you another example. Bromine. Now bromide. 35. 80. Then how many protons? Always this smaller number, 35. How many electrons? Be careful this time. There is a negative charge. Negative 1 charge. This means Br gain extra electron from others. Initially, if no charge is 35, now gain extra, so 35 plus 1. is 36. Be careful, negative charge is plus, positive charge is negative minus. If -1, you plus 1. If -2, you plus 2. If +1, you minus 1. If +2, you minus 2. Okay. Then, how many neutrons? Neutron always mass minus proton number. So 80 minus 35 is 45. These two, not in the textbook, but these two give you more knowledge about how many protons, how many electrons for iron. Okay. Then take a look at question 48 about naming compound or naming ions or whatever. Give the formula. I show you several of these, not all of them. 48. Let's show you couple from 48. KClO. K clearly is potassium. ClO. From the lecture part, we have series of acids from ClO. So we have HClO4, HClO3, HClO2, and HClO. Right. This we call perchloric acid. This is just a chloric acid. O2, chlorous acid. And on the 1O, then we give prefix hypochlorous acid. If hydrogen are lost, becomes ClO4 minus, then still there, perchlorate. Right. So perchloric acid becomes perchlorate. And this is chloric acid. Hydrogen loss becomes ClO3 minus, then just chlorate. And chlorous acid, hydrogen loss, the ClO2 minus, then this name is chloride, ITE. And this HClO, hydrogen loss, becomes Cl minus, then this name is hypochlorite. Right, so clearly ClO minus, the name is hypochlorite. Okay. Then take a look at the next one. CsClO3. CsClO3. This is E. CsClO3. Cs, if you take a periodic table, Cs, the name is cesium, Cesium. From group 1A element. ClO3, clearly here is chlorate. All right, here this name is out of range of the camera. Let me rewrite. So this is ClO minus, and the name is hypochlorite. Prefix hypo, this means only one oxygen left. And then take a look, next one, FeO. G. FeO. Fe is a transition metal, so we need to point out is a charge with a Roman number. So what is the charge in Fe? You need to figure out the oxygen first. So oxygen normally -2 charge in a compound. Then this Fe will be +2. So this name will be iron 2. So iron 2, Roman number 2, oxide. The Roman number. This is Roman number 1. Then this is 2. This is a 3. Right. This is a 4. And this is a 5. Looks like a V. Okay. So iron 2 oxide. Then take a look at H. Fe2O3. What is the number? What is the name? So Fe clearly is iron. Then what is the charge for this Fe? Oxygen -2. And you have 3 oxygen. So -2 times 3 is -6. Then 2 Fe. Total, no charge. Then this Fe charge will be 3, right? So Fe iron 2, iron 3 now. The name will be iron 3 oxide. The reason is you have 3 oxygen there. Each oxygen is -3. Each oxygen -2. Then 3 oxygen -6. -6, then 2 iron must be +6 because this compound has no charge. 2 iron +6 and each iron +3. So the name will be iron 3 oxide. Then take a look, number 50. Question 50, write the formula for this compound. I just show you here, pick it up from number 50. Let's see, B, strontium chloride. Number 50, give you name, ask you formula. Let's say B, strontium chloride. Strontium, okay. TiUm. STRONTIUM. Strontium chloride. The strontium from group 2A. From periodic table, this is group 2A. Okay. Use the periodic table. Strontium group 2A. The symbol is Sr. Chloride is Cl. How many chloride you need? Cl group 7A. Normally -1 charge, and strontium group 2A normally +2 charge. This means you need 2 chloride to balance 1 strontium. Then next is question C. Perchloric acid and perbromic acid. No. Perchloric acid. C. Perchloric acid. See, we just learned in question number 48, we explained perchloric acid, chloric acid, chlorous acid, hypochlorous acid. So perchloric acid, this means more oxygen in the formula HClO4. If chloric acid, then HClO3, right? If chlorous acid, then HClO2. Then hypochlorous acid, HClO. So perchloric acid, HClO4. Then E, disodium ammonium phosphate. Disodium means you have 2 sodium. Sodium's Na. Ammonium, NH4. Be careful, here is ammonium. If ammonia It will be different. This is NH3. Ammonium is NH4 plus, one positive. First phase, PO4. Then how many first phase group needed? First phase is 3 negative or -3. So ammonium is positive 1, sodium is positive 1, and then 2 sodium positive 2. 2 sodium positive 2 plus ammonium positive 1 totals positive 3. First phase is -3. Think balanced. Only one first phase is needed. This is the correct formula. Then I, mercury 2 oxide. Mercury symbol is Hg. Oxide is O. Oxide is -2. And mercury 2 means positive 2 charge. So 1 mercury, 1 oxide. Together, no negative charge. J, mercury 1 iodide. Mercury 1. That means charge 1. But here is very special. Mercury 1, this normally is 2 mercury bonded together, then total positive 2. And iodide is iodine from group 7A -1. Then you also need 2. This is mercury 1 iodide. This is very special. Normally, you may think mercury 1 iodide will be this, but actually it's Hg2I2, because mercury 1 is 2 mercury bonded together, total positive 2. Then each mercury is positive 1. So the formula is Hg2I2. Show you one more question. 56. Ask you, George, this formula is a molecular or compound or element? A molecular. So first of all, this formula, clearly this is molecular. And more than 1 atom there. Is a molecular. Is this a compound? Yes, because you have 2 different elements there. Sulfur, oxygen. This is a compound. B. SH. Is this a molecular? Yes, you have 8 sulfur atoms bonded together. This definitely is a molecular. Is this a compound or element? Not a compound, because only 1 element is there, sulfur. To qualify as a compound, you need at least 2 different elements. Like you have sulfur, you have oxygen, 2 different elements, chemically bound in a fixed ratio. And here only 1 element, so not a compound, just a pure element. Just like O2 is an element. Let's see. We skip C. CS is a free element, not a molecular, right? Let's say D. N2O5. Is this a molecular? Yeah, you have 2 nitrogen atoms bound with 5 oxygen atoms. This definitely is a molecular. Is this a compound? Yes, because you have 2 different elements, nitrogen and oxygen. This is a compound. let's stop here. And next class we'll have quiz 2 for chapter 2. So practice the rest homework problem solving.